Hello, everyone. In the last lesson, we studied the theoretical knowledge of cylinder wear measurement. In this lesson, we will do some hands-on practice and see how cylinder wear is actually measured. Before the operation, check the tools used for cylinder measurement: the external micrometer, the base, the dial bore gauge, the vernier caliper. Step 1. Set the reference. The standard cylinder diameter of the Chang'e or 180 single-cylinder diesel engine is 80 mm, and the piston stroke is 80 mm. Since the cylinder wears larger over time, we use 80 mm as the reference. Adjust the external micrometer to 80 mm and install it on the micrometer base. Adjusting the direction according to personal preference. Step 2. Install the gauge. 1. Check if the micrometer head is flexible. 2. Install the dial gauge head. It is not necessary to zero the dial gauge at this point. Since the range of this dial gauge is only 3 mm, which is relatively small, try to control the compression of the dial gauge head to within 0.5 to 1 mm, that is, half to 1 full turn. Tighten the fixed screws and zero the dial gauge for the first time. You can place the dial gauge horizontally to avoid excessive force causing too much compression and exceeding the dial gauge's range. 3. Choose the appropriate fixed measuring head. Due to cylinder wear causing an increase in cylinder diameter, each maintenance level of the cylinder should not exceed 1 mm, that is, the current cylinder diameter is greater than 80 mm and less than 81 mm. Choose the fixed measuring head size based on this. Here, we choose a fixed measuring head with a size range of 74 to 82 and put on the locking nut, but do not tighten it. Check again whether the movable measuring head of the activity operates normally without getting stuck, and ensure that the dial gauge linkage is flexible. Step 3. Calibrate the gauge. Use the external micrometer to calibrate the dial bore gauge. The reference size of the external micrometer is 80 mm. When the assembled dial gauge is placed on the external micrometer, adjust the size so that the dial gauge is compressed and turns clockwise by 1 circle, which is 1 mm. At this time, the dial gauge returns to the 0 position for the second time, and the fixed measuring head is tightened. When you take off the dial gauge, the movable measuring head relaxes and springs back by 1 mm, and the dial gauge turns counterclockwise by 1 circle and still returns to the 0 position. Note the following. 1. The dial gauge is a precision measuring tool with a range of 3 millimeters. The compression amount when installing the gauge is 0.5 to 1 millimeter, and the calibration compression amount is 1 millimeter, leaving a small safety margin for the dial gauge. Be careful not to exceed the range during the installation and calibration process. 2. During the calibration process, the fixed measuring head should be adjusted in length from short to long to avoid exceeding the dial gauge's range. 3. During the calibration process, the dial bore gauge should grip the insulating sleeve part. Fingers should be properly positioned to support and hold the fixed and movable measuring heads. When adjusting to a compression amount close to 1 circle, observe the head and gently swing it left and right. When the dial gauge pointer returns to the 0 position, the calibration is successful. Step 4. Measurement. Use the vernier caliper to take 3 interfaces at 10 mm, 40 mm, and 70 mm from the top dead center in 2 horizontal and vertical positions and insert the internal dial gauge for positional measurement. During the measurement process, observe the dial gauge head, gently swing it left and right, and observe the position where the dial gauge pointer returns. Due to the wear and enlargement of the cylinder on the 80 mm base. When taking readings, add the length of wear expansion to the 80 mm base by rotating the dial gauge's dial counterclockwise. For example, if the dial reading moves counterclockwise by 12 divisions, then read 80 plus 0.12 is equal to 80.12 mm. The specific value should be based on the actual measurement. Step 5. Calculation. Fill in the measurement data into the work order, whiteboard table, and calculate the roundness and cylindrical error of the cylinder where based on the formula, roundness equals maximum measurement value minus minimum measurement value, divide by 2, cylindricity equals maximum measurement value minus minimum measurement value, divide by 2. Among the 3 sections of the cylinder, there are 3 roundness errors, and the maximum value is taken as the conclusion. Cylindricity error is the error of the entire cylinder, calculated using the maximum and minimum values of all data. Step 6. After the work is completed, fill in the work order. Clean the workstation and restore the equipment. Cylinder measurement involves a combination of various measuring tools and requires calculations, which is quite challenging. It is necessary to study the principles diligently and practice regularly. Let's briefly summarize the operating steps. Step 1. Set the reference. Step 2. Install the gauge. Step 3. Calibrate the gauge. Step 4. Measurement. Step 5. Calculation. Step 6. Fill in the work order. Finally, please answer, in the third step, calibrate the gauge, why should the measurement head length be adjusted from short to long? This concludes today's lesson. Goodbye, everyone.